Hey everybody, thanks for joining us as we're starting this transition into taking notes on the computer versus taking notes at home. We're going to test try and see how this works for us today and give me your feedback tomorrow. Alright, your target that you're going to be looking at today is that you're going to be able to solve systems of linear equations by graphing. Keyword here is graphing. We're going to go over many ways in which to solve systems, but our first way is graphing. You are going to title this in your notes, Graphing Systems of Linear Equations. Your essential question that you are going to answer at the end of this video and bring back tomorrow is, how do you solve systems of linear equations? There's this huge thing with the videos that you can pause at any point. So please go ahead and pause now so you can finish writing down all these slides. Thank you for pausing. Okay, in class, remember we learned that a system is two or more equations, and the solution to the system is the point at which these are intersecting. So the point at which they cross. Right here, intersection. That's the solution. The steps that we are going to go through, the 3 steps for graphing, are we're going to graph first, then we're going to estimate the point at which they do cross, and then we're going to check by substituting in. Let's go over that in an example. Our first example we are looking at are 2 equations given to us, are given in the perfect form. That's y equals mx plus b. Why am I saying perfect? Because this is the form that is easiest to graph. So step 1, we're going to graph. We're going to graph it. Okay. Step 2, and remember we graph it by putting up 5 and going up 2 over 2. So 5 up 2 over 2. You can also go down 2 over 1, and making sure our line goes all the way through that window. Okay, step 2, we're going to estimate the point at which they intersect, and our estimation is -1, 3. Step 3 is that we are now going to check our points by substituting in -1 and -3 for x and for y, and to see if the statement is true. So let's go ahead and look and see what happens when you substitute in. So 3 is y, -1 is x, and that algebra worked out. Next, 3 is y, -1 is x. Let's see if the statement is true. Yes, it worked out. And look, they worked out to be the same solution. Interesting. Okay, the solution to the system by graphing was -1, -3. All right, let's go through with some of our own examples. And yes, you can put this on your graphing calculator. It will get you the same answer. 3 examples that we're going to go over. And I need you to practice on your own as well. So make sure you're using that pause button in your video. Pause is super important. Okay. First step, we're going to graph each of these equations. Graph, so this one has an intercept of -1 and a slope of 1. So -1, slope of 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. That means we can also go down 1 over 2, down 1 over 1, not 2. Great. Now I hope your line looks better than mine. All right, here's our first one. Our second one, our intercept is -3, so +3. And our slope is down 1 over 1, down 1 over 1, down 1 over 1. I should have already noticed something, that we have found the intersection of these 2 points. Oh, and my line looks horrible there. So let me go back and erase that. Let's follow this line. That's a better line. Okay. And we already found the intersection right here, and that's 2, 1. 2, 1. Last step is that we need to go through and check to see if 2, 1 is our intersection. So let's go ahead and plug that in. It's negative, so y equals 1 equals 2 minus 1. Does 1 equal 1? Yes. All right. 1 equals negative 2 plus 3. Does 1 equal 1? Yes. Good. So the solution to number 1 is 2, 1. All right, pause the video and you go ahead and try number 2 on your notes. Thank you for pausing your video. Let's go ahead and get started with number 2. The first step that we're going to do is that we are going to graph our y-intercept. Sorry, I did a really big pen. I don't know why. We are going to graph our y-intercept. Mine's 4, so I'm going to go by 2's on my graph. So 2, 14, 4, 6, 8, 10, 12, 14. Okay, and the slope is negative 5. So I'm going to go down 5 over 1, down 2, down 4, down 5 over 1, down 2, down 4, down 5 over 1, down 2, down 4, down 5 over 1. Okay, I've been saying over 1, so I've been going by ones. So down 2, down 4, down 5, and over 1. Down 2, down 4, down 5, and over 1. All right, here's our first line for number 2. Great, first line for number 2. Now let's go ahead and graph our second line. So negative 10 is our intercept. Negative 2, negative 4, negative 6, negative 8, negative 10. Put a point there. Our slope is 1, rise 1, run 1. So rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. All right, I found the intersection. Do I have to keep going? No, you don't have to keep going. We can stop right here. Here's where our intersection is for number 2, and that's 4, negative 6. 4, negative 6. Next, we're going to check to make sure that works out. So, negative 6 equals negative 5 times 4 plus 14. Let's see if that works out. Negative 6 equals negative 5 times negative 4 is negative 20. Plus 14, does negative 6 equal
Good morning, Rubik's Cube is in room 13. Rubik's Cube, room 13.
All right, let's go check our last one. So we have negative 6 equals 4 minus 10. 4 minus 10 is negative 6 equal to negative 6. Yes, our solution, the point I need to see in this ordered pair, is 4, negative 6. All right, go ahead and try number 3. Pause your video and try number 3. Thank you for pausing. Let's go ahead and get back to it. All right, our intercept is 0 because there's nothing there, so we're going to put down a 0, and our slope is 1 over 1. 1, 1, 1, 1, 1, 1. Increasing, we're good. All right, I'm going to keep going just a little bit further, so I have a lot of information to find the intercept. All right, I do need you to connect your dots on your paper. I'm going to leave it like this because my lines are always so awful. All right, our second one, the intercept is 1, and we're going up 2 over 1. Up 2 over 1. I should use a different color. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I see I'm getting no closer to this line, so let's go and switch it the other way. Down 2 over 1. Ooh, interesting. Down 2 over 1. Down 2 over 1. All right, I found my intersection right here where my black and purple pen met. So it's safe to say that this one is approximately 1, negative 1. Now let's go ahead and check. So does negative 1 equal 1? No, sorry, this is negative 1 because it's on the negative side. There we go. Does negative 1 equal 1? Yes. Good. So now negative 1 equal 2 times negative 1 plus 1. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. Does negative 1 equal negative 1? Yep. Our solution is negative 1, -1. All right. Thank you for doing your practice problems. Let's go ahead and switch it up. All right, for the next examples, you can change them into the y equals mx plus b format and then graph from there. Or again, you can 0 x and y and plug those in here. Your choice. It's up to you. Our first example, I want to try the mx plus b. So go ahead and pause your video, solve for mx plus b, and then replay the video. Go ahead and pause. Thank you for pausing. Let's go ahead and go through this. All right, I'm going to change this. This one's already in y equals mx plus b. Perfect, but this one needs to be changed. So if I take away x on both sides, I'll be good. So take away x, y equals 2 minus x, or y equals -x plus 2. All right, so now we're good. No longer going to use this one, but we're going to use this one to graph from. All right, first step, go ahead and get the intercept. So I need -7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Ooh, kind of off. I know. These are all negatives. I apologize. All right. And then we're going to go down 4 over 1. So opposite, because it's going to be way off. I'm going to go up 4. 1, 2, 3, 4 to the left 1. Up 4. 1, 2, 3, 4. Oh, let me double check that. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1 up here. Okay. I'm definitely going to need a line to see this one. Awesome. Okay, now let's try the next one. 2, 2, and the slope is -1, so down 1 over 1, down 1 over 1. I'm getting further away, so let's go the opposite way. Up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. Here's the point at which they intersected. And we're going to check to see if -1, -2, -3, -3, comma 5 is a solution. So 5 equals -4 times -3 minus 7. 5 equals 12 minus 7. 12 minus 7, does 5 equal 5? Yep. Last check. 5 equals -3 plus 2. 5 equals 3 plus 2. Does 5 equal 5? Yep, and we're good. All right, go ahead and pause your video and try number 5 and number 6. 5 and 6. All right, really quickly, here's how you do the zeroing. So if I plug 0 in for x, y is going to have to equal -5. Let me show you. 0 minus y equals 5. Make y positive. Y equals -5. Okay. 0 in for x. I want to plot this point because this is the y-intercept. -5. 1, 2, 3, 4, 5. Okay. Now I'm going to plug in 0 for x. Sorry, I just did that. 0 in for y. So x minus 0 equals 5. Go ahead and plot x equals 5. 1, 2, 3, 4, 5. Let me count that again. 1, 2, 3, 4, 5. Awesome. Here's my line. No, I didn't go by slope. Here's going to be a rough approximation. Make sure your line is very straight. Okay, do that for this one as well. If we plug in 0 for x, -3 times 0 plus y equals 1. Y equals 1. So I'm going to plot at 1 for y. 1 for y. All right, we're going to plug in 0 for y now. So -3x plus 0 equals 1. Solve for x. X will have to equal -1/3. So we're going to plug in, put out -1/3, which is like right here. So here's this line. All right, you're going to have to approximate where that is, either that or graph it. So go ahead and do the next two examples, and I will tell you the answers in the next slide. Thank you for pausing your video. All right, for that last problem, for the last two problems, number 5, you should have -2, -7, and number 6, you should have gotten 4, -8. All right, your next step is now to answer this reflection. This is your next step, and then you're going to go to Schoology and take that 4-question quiz. Oh, well, it's not a quiz, it's just a checkpoint to see how well you did. That's 4 questions, and I'll see you tomorrow. Bye, guys.